Hi guys, my name's Kevin Toppenberg and I have been restoring this beautiful 1935 South Bend Lathe. It's got a 15-inch swing and a 6-foot long bed. This time we're going to get this gearbox mounted on, and along the way I burn my hands with chemicals. We learn all about gears and we find out why if your teacher in math won't let you bring in a calculator, maybe you could sneak in a lathe to do the calculations for you. I'm just kidding. If you enjoy this video, please give it a thumbs up, and I'd love some comments. I'm a really small channel, so I try to get back and respond to everyone. I'm still finding my way in the storytelling of all these videos, and so I love the feedback to find which things people like or which things I could do better. I'm gonna get started on this gear change box. I disconnected the lead screw that went through here with 2 nuts. I've got it sitting over there on the floor, and I'm gonna start trying to get this thing cleaned up. Guys, I've been working on this gearbox for several weeks now, and when it came time to edit this video, I had 2.5 hours of footage, which I'm gonna try to boil down to about 20 minutes. So we're gonna have to cut out a lot of stuff. I'm gonna put a link down in the video description that shows all of the footage. If you're working on a South Bend lathe restoration of your own and want to see how I address some particular issues, I'll have that link for reference. Otherwise, I'm going to skip over a lot of the disassembly and just try to hit the highlights here. I'm leaving a big mess. It's going to look nice when I get it all cleaned up though. It's a beautiful day today. Spring is in the air. I've got red-winged blackbirds singing in the outside the shop. I don't know if you'll be able to hear them or not. So I went down to Knox Makers last night. That's in Knoxville, Tennessee. And my friend Dave there, and also Billy, helped me get this gearbox taken apart. And I'm gonna go through all of the parts and how they go together and everything later. I will say, in my never-ending comedy of errors, so I was down in Knox Maker and I was working with the parts washer, and I was cleaning it up, and to me it felt like there was a detergent in it because it was kind of slippery. And then Billy, the head guy, said, "You're not supposed to have your hands down in there, that's lye." And that slippery feeling was the, like I think they call it saponification, where the fat in your skin's breaking down and turning into like a soap. So I quick went and washed it, and luckily didn't hurt myself too bad. There was a little hole in my glove where a bunch of it had gotten in and sat there for quite a while. I was washing my parts for about a half hour and really kind of irritated the skin here, but I think it'll heal up. But always something. Now, one mechanical repair I was concerned about was a broken handle off this gearbox. Here's that arm welded back together. Again, my welding teacher did this. He used TIG welder with silicon bronze. This metal really was not taking the weld very well. We had an oven there. We got the whole thing up to 500 degrees and let that sit in that oven for a couple hours. So it was nice and warm. And then we put it back in the oven for about another hour afterwards to let it cool down. It looks like it's strong. There's an oil hole right there. And I think that's right where it broke. Got this fairly well sandblasted, especially in the corners. I'm gonna put Bondo on the right side, the front, and the left. I've put 2 coats and sanded. I did that all off camera. I'm gonna try putting some Bondo on here to smooth out those places where the brazing was. I have a lot to take off there, but I put it on thick so I have some room to work. This is the middle of March in eastern Tennessee. Yesterday I was in a short sleeve shirt. And then after the snow, the sun came out. It was just gorgeous. I was driving back from church and I just had to put my camera on. You only see days like this once a year or so. Beautiful. I've gotten another coat of paint on there. I also painted these gears black. Now I'm going to work on cleaning up the lead screw. I'm going to use this wire wheel to clean the lead screw. It's actually fairly soft, and I don't think it'll cause any wear on this. I'm going to use the lathe to clean the lead screw, whereas I have it spin, and I'm going to use this to kind of gouge out some of all that grime. So the first use of the lathe for a real purpose. I think that looks fairly nice. All right, another step done. This is one of the shafts inside the gearbox, and I just wanted to show something that was interesting. I saw some grease here, and I thought, well, I'll clean that out a little bit, and I sprayed some brake cleaner down there through one of those little tiny tubes like you get with like WD-40 or something, and out it sprayed right there. And so apparently, there's a hole, you can take out that set screw, and they drilled down in there, and apparently that spreads oil from this spot down to this spot. And then there's the same thing on this end. Oil that goes in here comes out there. And that also has a set screw on it, so that's kind of neat. So most of these shafts have these little felt wipers where you put oil in there, it comes out here, and then gets spread with this felt wiper. It's very dense. It almost looks like leather, but I think it is felt. But I'm having a difficult time finding replacements, so I'm gonna see if it's possible to clean them. So using that acetone as a solvent, you can see how much grime I got out. That was clean when I started. I think it looks pretty good. This end here still has some darkness, and that seems to be a little bit harder end. I'm actually gonna try soaking them in acetone for a little while to just let it kind of soften it up like I might some old dirty dishes. I looked on McMaster Carr. They only have 1/8 inch, which is a little bit different than this. I think this was 3/16. And it wouldn't be the right width, so I would have to, cut it down to size. And then apparently there's lots of different kinds of felt weights. It goes from like F1, I've seen up to F7. So this seems to be working fairly well. I was soaking them here in acetone. I don't know if that helps. I then have some old gasoline here. You see how black it's getting. And I just kind of rub it around in there. Just trying to loosen all of that dirt and everything up. Kind of twist it to squeeze it out like you might wring out a towel. I've then been taking this and just squeegee it out. And some of these have a little metallic fragments, I guess, from dust and grit and stuff, and I've been trying to make sure I get rid of all that. But it's already starting to look a little, the natural gray coming through. Where's my camera? Somewhere in there. All right. So I think I'm gonna be able to use those. I'm gonna go back and get the felts out of this. Let me show you what they're looking like now, and I'm gonna try doing a wick test with oil and see how it does. All right, I'm gonna give you a pro tip here. When you're putting this back together or when you're painting it, don't let paint go down in there. This little plunger has to slide in there, and it's quite a snug fit, and paint makes it so it doesn't work. So I took an old end mill and put it in there and kind of pushed up against the side and rotated, and that was enough to get the paint off the inside. So now that slides nice and smoothly. So I got that done. All right. I'm gonna start putting the gearbox assembly back together, and I found an excellent YouTuber called Halligan42 who had this same gearbox, and I'm following really directly step by step, so shout out to him. And we'll put on the press gear, then we'll put on the pin gear with the gear to the left. Then we'll put on the clutch gear with the gear to the left. And then have to rotate it to get up on that key. And then finally this final gear with the wick in it. And you'll have to pull some of this back out to give yourself room to put that on. All right, now we've got it on there. We'll try to slide everything over to the left. All right, so I've got my key here that's gonna press up on. So I'm gonna rotate that keyway that I can just see down in there and just try to seat it up on there. It goes on there a little ways before we have to start applying force. In order to get that on, I'm gonna hammer the shaft in this way, but if I do that, it's just gonna tend to push the whole thing out. So I'm gonna put a block in here, and the Halligan 42 guy, he manufactured a block that went right in there. I don't really have the ability to do that right now, so I've got these blocks just sitting around the shop that say 11/16. So I'm going to use a little wooden stick here. So I got some movement there. Now it's kind of tight up against there. So I tried all kinds of approaches to get that left gear pressed onto the end of that shaft by forcing the shaft up onto it. Just tried this and that. Ended up having to use a piece of aluminum to hammer on there. I had to get some wooden pieces to shove down in there to keep everything tight so it wouldn't just jump out when I hammered it. Tried using a furniture clamp. That didn't work. But finally, after just trying and trying, finally got it on there and it seemed like it was working. All right, the next thing to do is to work on this pin gear. Now this pin gear has a slot that goes up over that key, and we used that when we were getting it on. But once it gets down here, it doesn't go on that key. But that slot where the key went is supposed to have a wiper in it. I've got this soaked with new oil, and I am able to just take my little probe and just push that in there. Okay, now we're gonna put the pin in, and the pin is off center right there. And when I'm over here, to get it just right, I can see through it. Trust me, I can see through that hole down to the bottom, and that pin will go all the way through. This one has an angle at this side. This one has an angle at that side. All right, our next step is to put the ball in the detent. So there's my ball, and that will go in there. And then next comes the spring. And then comes the set screw. What if I got that in too tight? You know, that's not linking up on the left. Those castle nuts are not engaging. So if you notice here, when I turn this, the whole shaft turns, and I cannot turn it separately from this big gear. So that tells me that there's too much friction between this, and that tells me that this gear is not pressed on enough. So I'm gonna take that pin back out, work on getting that on a little bit more. Got a piece of brass and try to persuade it along. I think it moved in a little bit, but I was gonna show that here is that little hole. That's a oil communication hole. I'm gonna put some oil in there. Beside it is this groove that the pin's gonna run across to retain that while still being able to spin. Okay, so see, that can now spin. It couldn't spin before. Now my detent can go all the way over. So that's proper. So let's get oil everywhere. I'm gonna try to get this shifter on. So the shifter has a slider that goes in that slot. Yeah. That was snapped off before and now it's working like a champ. Slowly, slowly, she comes back together. Good morning. I don't know if you can hear it, but rain on a tin roof. We'll keep the weather out today. We're ready to do the next shaft on this gearbox. That's what it looks like. There was quite a bit of scoring on this. I'm not sure, one of these, the oiler was just completely blown out and probably just letting dirt fall down in there because that took quite a bit of scoring, but I put that in my lathe and polished it up. There's going to be some gears, spacer, a gear, spacer, and gear. So these spacers are going to be in the middle and they're keyed. When I went to bring the shaft off, there's a nut that goes right here. And as you go to turn that nut, the entire assembly just turns. You have nothing to hold back with. So we ended up putting some channel locks on here, but it wasn't very satisfactory. It was kind of difficult. What I'm gonna do is I'm going to drill some holes in here so that I can use a spanner wrench to provide tension. Here's my poor man's mill setup. All right, I think these turned out real nice. And I did that for both of these. I've got a nice square base. And then my spanner wrench comes in and will hook into that nicely. The spacing of the gears is going to be 1, 2, 3, then a spacer, then this gear which has rounded edges, and then another spacer, and then 1, 2, 3, 4, 5. And they'll need to be put on from thickest to thinnest. All right, I got that all on. I'm very happy with how these grab holds went for my spanner wrench. I thought that worked real well. As you're putting these gears on, when you get farther and farther, it gets difficult because you've got to get them all rotated so that they go on to the key. The Halligan 42 made the suggestion of putting a snap mark right over the key slot, and I forgot to do that, but I ended up not really needing it. I was able to just kind of rotate it until I could feel it, felt like I was picking a safe or something. The other thing is getting that screw on at the very end is difficult. So what I did is I put this screwdriver through the hole and just propped the nut on it, just kind of hanging there, while they then came and manipulated the shaft until I could get the shaft to go onto the nut. But otherwise, that's a little bit tricky. Our next part is to put this arm, which I think is sometimes called a banjo arm. And that's going to go on here like that. But before I do that, I'm going to put the gears on. And it's going to go this gear, then this gear. So this gear here, I've put another, I've replaced the cleaned felt. That's going to go in there. I've made sure that the oil hole is clean. And that's going to go onto there. Now it took a press to get this out. So I think it's a very tight fit. I'm going to take that over to my vise and put a spacer here and squeeze it back together. I'll do that off camera. All right, our next shaft to put in is this one. It's a sliding gear, I believe. It has a, screws on, there's a spring, and then underneath there is a ball for a detent. And that detent, I believe, goes in this groove or that groove. So that's going to come in like that. I want the oil hole to be above the center so you can put oil in it. It'll run downhill into the gears. Looks like it's going in with just my soft blow hammer. Now I have enough threads here that I can just pull it the rest of the way with the nut. All right, next job is to put this onto here. I've been thinking about these old machines as I reassemble this. These things are just massive in ways that you don't see today. And I think part of that is the difficulty of their manufacturing process. They had to make a wooden model of all these things and then make sand castings. Whereas now we have the ability to machine stuff out. They can also do computer analysis to find out where the areas of stress are so that you can beef up the areas that count and get rid of all of the extra metal that doesn't really do anything. It's just sitting along there causing weight. Because man, this stuff is all so heavy. Our next step is this bigger gear. Like this, it's got the taper pin and a collar at the end. That's going to slide in here. And then it's going to go through this arm. These things are all wicking very nicely. I laid them on some oil and they promptly filled up with nice soft oil. When I squeeze it, it comes out. So I think it's going to work well. I don't think they do this kind of stuff anymore as far as felt and all that. I guess they use ball bearings packed with grease. Because it just seems like there are 100 places to oil this thing. I saw a video one time about starting up a steam engine. Took like, 6 man-hours or something to go around and do all the oiling, and had to do that, every day or every something to go through and lubricate all the areas. That's just craziness. I think that's it. No, I gotta put this plate on. Oh, I also need to get in the oil tube. I hope I haven't done that too late. Oiling tube goes in right down there, and it comes up and it goes, there's like this little well that's out, and it's got 2 oil holes. There's this one which goes to this area. This second little hole goes down to here. So I guess you have to oil it when the thing is in that position. Very strange. Well, I think that looks better. But next we're going to put this on. There's some pins that go there and then some screws. That's what's going to hold this gear selector in the right spot. And then I'm going to clean out these holes here. It's time to put this, which I guess is some sort of a tool tray, up on top there. That's one of the first pieces I finished, so it's been sitting on the shelf waiting a while. It's a big day for it. Very nice, very, very nice. I bought some Gitz oilers and I got a message, eBay said they delivered them, but I don't know where they are. I may have to order another set if I can't find them. Now instead of push pins to secure this on, I'm going to use number 632 brass screws. Now here's the brass tag that shows the lead screw speed and the threads per inch based on the various gear level positions. You can see initially it was fairly dirty, but I was able to clean it up with some Scotch-Brite and some fine sandpaper. I think it looks real nice. It took away a little bit of the red color, but I think it's going to be good. I don't have any brass machine screws right now, but I do have these 632 zinc ones that I've put on. I think they'll do fine, and then when I swap them out for some brass ones, I think it'll look good. I'm excited because this part is almost done. Let's talk about gears for a lathe. What do we need gears for? When a lathe is running, you're going to have your part spinning in here, and you're going to have your tool move along. And it moves along through this lead screw. I don't know if you can tell, but it's turning. Then I flip this lever down. So when it's all engaged, you can tell this handle is very slowly moving. So how does that work? We got the spindle, goes through the rocker arms, which tell whether it's going to go forwards or backwards. There's no gear reduction there. Then it goes to here. So we're going from a fast speed and it's stepping down so that this doesn't move very fast. And then that turns this lead screw, which connects. I don't know if you can see in there, but there's like clamps that open. It kind of opens and then closes down over that lead screw. When it closes down, it engages, and then it's going to move as the lead screw changes. Now this particular lathe, if I ever want to change the ratio of how, or ever want to change how fast this is going, I've got to have a different gear train. And so there are tables that come with this lathe, you can download it, that say, okay, you have to have this many teeth and connected with that many teeth, and you go all through. And so when I got it, I didn't have all the gears I needed. They call them change gears. So I actually 3D printed them, and I've used them for several years, and I've never had a broken tooth. They actually work pretty well. Now, does it matter just exactly how fast this turns? And it doesn't if you're just moving your tool along for cutting. But let's say you want to do threading. Let's say you have a piece of round to here and you want to make a bolt. So then you want it to move forward at a very precise amount. For every one turn of this, you're going to want to go forward a certain amount. So for example, let's find a bolt. And let's just guess that this has 20 threads per inch. I'm just making that up. So that means each time it turns around, I'd have to do the math, but it's going to go forward a certain amount. So you want that relationship with the lead screw. And this is just difficult. You've got to pull out a manual, you've got to take it all apart, you've got to get the pieces on, you've got to then reposition everything so that all the gears are just touching exactly. So that's why it is so nice to have a gearbox like this where it's all built in and it does it all automatically. So I'm really excited about having that. The next thing I need to do is to get the lead screw in. I wish I could mount this and then put the lead screw in, but the lead screw has this gear, has to be inside, and when this is mounted up against the side wall of the lathe, there's no room to get in there and work. So as far as I can tell, it's got to be done now. Let's look how this gear train works. I've got the unit flipped upside down. This is where the power is going to come from the spindle. For every rotation, we're going to have less teeth. And then it's going to connect to this bigger gear. Now, there's going to be two modes. We'll talk about each mode separately. So first of all, we here to there to there. Then this just becomes an idler gear, probably a 1-to-1. But you also can switch to this mode where that pushes in. So now this is acting as a double-decker gear. And as that turns, you can see we get much faster rotation down here. So this is like a high or low selector. As the power comes down here, let's watch. You see that? This shaft here makes this gear turn. Now this selector arm, it swings because it has to be able to engage with gears of different diameter. From here, where it's going, if it was swung around, I have it upside down, so it's going to swing around. That one's going to touch either that smallest gear. You can see it has all the different gears that it can connect to, all the way except for the last one. The last one, it would not be able to connect to because you see that one lines up to the next to the last one. But that last one then connects to this secondary shaft. Let's just look at it here. I'm going to put it into not connected at all. As that turns, so this one also turns. But you see that is just slipping on there. It doesn't actually do anything. In order for it to do something, it's got to connect in with this. Let's put those castle gears right like that so that engages. That will then connect to this. And then because of I don't have enough power of my strength, I'm going to rotate this to show it the other way. So now as that rotates. So we have a shaft with 8 gears connecting to a shaft that has a handle on it. The shaft that has a handle on it has a slipping gear on the left, a slipping gear on the right, and a center sliding gear that's actually connected to the handle. It's this middle gear that has a key that binds it to the output shaft. If we slide that middle gear to the right, it will connect to the gear ratio on the right. If we slide it to the left, it'll connect to the one on the left, and it connects with those castle gears. If the handle is in the middle position, it connects the shafts in a 1-to-1 ratio. The slipping gears on each side, the left and the right, will continue to spin, but they don't do anything because they're not connected with the castle gears to that shift selector middle gear. So that's how we have kind of a low, medium, and high selector from here. We have a multi-gear selector from here, and then we have a high-low here. 2 times 3 would be 6 times 8, 48 selections. And that should equal up to all of these. So that's how that works. We all know that a digital calculator can multiply 2 numbers together, but did you know that gears can do the same thing? Let me show you. I've got a double-decker gear here. This lower part has 40 teeth. This upper part has 20 teeth. Now imagine I've got a motor that's spinning this, let's say 100 times a minute. For each one of those 100 times, there's 20 teeth. So I'm spinning this at 100 times. 20 teeth are going by. But for every time you have these 20 teeth, this actually makes 40 teeth go down here. So that ends up to being a 2 times multiplier. Alternatively, we could have our motor driving the lower part at 40 per revolution, but then that actually only outputs to 20. So this would be dividing by 2. So you take the ratio of the 2 teeth, and then that gives you either the multiplier or the divider. So this gear has 32 teeth. This one has 46. This one has 36. So you can imagine all the different ratios that you can put to multiply or divide the number of times per minute. So let's say we take our RPMs of our motor, R. We could then, for each step we go through in one of these double-decker gears, it's going to be R times, like here it might be times 2, and then you could have it by times some other ratio, and you can actually tailor the output RPM of your shaft, and that's a multiplying or division using a mechanical device. It's a mechanical calculator. So my little Craftsman lathe has 1, 2, 3, 4 opportunities to have a double-decker system. There's one ratio that will convert from imperial to metric. This manual on lathe operation for the Craftsman lathe is actually a pretty good book. And then you can see it's got all the different threads per inch that you can get for that. And that's all imperial. Some of them are exact, some of them are off by 1 with 3,500, so pretty close. And then for metric, it's got this as well, using these different ratios. So it's a pretty cool system, but man, is it a pain in the butt to change all that out. So it's kind of a pick your poison. I'll see how that new one's gonna work, whether that'll solve most of my needs. All right, it's time to get this mounted. I've got it up in my hoist, as graceful as can be. Let's see if we can get it mounted here. There, my friends, is the gearbox mounted. The next thing that needs to be done is this will need to be loosened so it can rotate, and then this holds it in place, and we need to set the gap on the gears probably a little closer than that. A piece of paper is about 3 or 4 thou. I'm going to use this to set the gap on the gears. All right, I'm going to put that there. I can definitely see a gap between the base of the tooth and the next gear, so I don't think it's going to wear. That looks similar to the spacing on the other gear, so I'm going to go with that. Next, there's a bolt that's we've got it attached up here by 3, but this end might just flop around. So there's a bolt that goes in that pulls it into the base of the headstock, whichever one, I guess the headstock end of the ways. And then, so it doesn't put too much stress on that little cast iron arm. It's got these little counter force. I guess they're kind of a set screw. Good. I found my little package of oilers, And I'm gonna put those in there, but before I do that, I wanna put a coat of clear coat. I kind of jumped the gun. I should have put the clear coat before I mounted it, but I should be able to put the clear coat on that quite easily. Spring is in the air. Let's get some clear coat on here. I don't know if it's coming on that video, but there's a bird just singing its heart out there. Whew, I got the garage door open. This stuff's toxic. This clear coat you mix up 4 to 1. So I usually just use a tablespoon. 4 of this to 1 of that. But man, it makes a lot and it goes a long way. So I didn't know what to do with it all. So I went back, I had painted the inside of this black because I'm guessing grease is gonna go everywhere. And I don't know that it needs clear coat, but I thought maybe it would add some smoothness and make it easier to clean up oil in the future. I also added some to the black that I had put in here. So I'm gonna come back now with the propane torch and just hit any little bubbles I've seen. I've showed that before, so I'm not gonna repeat that, but it's cool because all the little bubbles pop. I worked on the oiling a little bit. Then I did 1, 2, 3, 4, 5. Then I put 6, 7, front 8, 9, 10, 11, 12, 13 places there. I'm probably forgetting some. I want to work next on these tags. This one, I think I probably can do the paint and then sand the top because that one's a little bit more substantial. And then maybe this as well. Let's see how all these gears work. I think this thing is just designed to dribble oil. Aesthetically, I don't like it, but I think that's just the way it is. So here are these oilers. You push this little cotton down inside there like that. Then we come over here and we stick that in there like that. And I have the hinge down so when I flip it down, it oils better. If I can get that in there. And there I am. I think I may rotate that a little. Well, that's fine. All right, I'll do the others. I got that label mounted. I got that label painted and mounted. Got this one that says don't pull while lathe is running. I've got that painted and mounted. I've got my gear cover mounted. And you know what that means? The gears are done! Yay! I think it looks pretty sweet. All right, guys, thanks for watching. That's been fun to see it all come together. I got my shifter lever here. It's gonna go to 11, so I'll have to find something to do with all this power. The next thing we have to do now is the carriage. And to be perfectly honest, I'm terrified of this carriage. It's super heavy. It's got a lot of mechanical parts, I think, inside there. So I've got to take that whole thing apart and clean it. And this is all to say that I think it's going to take me quite a while until my next video comes out. So please hang with me in there, subscribe, and so you'll know when it comes out. Thanks. Peace out.